Good morning, my dear students. In the last class, we will discuss about types of solutions, that is, gaseous solutions, liquid solutions, and also solid solutions. There are 9 types of solutions. Here it is based on the nature of solute and the nature of solvent. It is, that is, the physical state of solvent and physical state of solute. Then this is the second session for solutions here, and in this session we mainly discuss about solubility of a substances in liquids, and also it is a solubility of solids in a liquid, and dissolution here, and crystallization, saturated solution and unsaturated solution, and effect of temperature on the solubility of solids in liquids, and effect of pressure here. And next we go for this solubility of gas in a liquid, and solubility of a gas in liquid based on Henry's law here, and the different forms of Henry's law here, and applications, and effect of temperature and pressure. This is syllabus in a second session. Then this is what is meant by this solubility here. Solubility means here broadly speaking, here solubility means solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent at a specific temperature. Since here solubility of a substance in a particular solvent depends upon temperature. A temperature varies, here solubility also varies. That's why here solubility means solubility depends on temperature. It is a temperature dependent. Here solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent. For example, take this is here solvent is taken as water. Water is one of the solvent. It is for this water here. You have taken 100 ml of water. For this 100 ml of water, here you are adding this is glucose, or if you are adding sugar, or if you are adding the sodium chloride like this here. If you are adding sugar at a particular temperature, at a room temperature, at about 25 degrees Celsius, it is at a particular temperature. Here what extent of sugar which is soluble at a particular temperature in 100 ml of water, this is called as solubility. It is okay. Then solubility, here this is the definition about solubility. Solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent. In a specific amount of solvent, here how much amount of solute that can be dissolved at particular temperature is called as solubility. Then solubility of a substance, the solubility of a substance in a liquid depends upon the nature of solute. This is sugar is called as a solute. Here water is called as solvent. This is called as a solute, and this is called as solvent. Solubility of sugar in water depends upon here nature of solute, and it depends upon the nature of solvent, and also here depends upon temperature and pressure. Here temperature, pressure varies. Here solubility also varies. These are the factors affects the solubility. One is nature of solute, or one is the nature of solvent, or one is called temperature and pressure. Then after this, here we are discussing about it is solubility of a solid in a liquid. It is then solubility of solid in a liquid. For example, here that is sodium chloride. When the sodium chloride dissolved in water, here this is sodium chloride, and also it is a sugar. Sodium chloride, sugar dissolved in water. But here, if you take this is called as benzene, that is called as naphthalene and anthracene. Naphthalene and anthracene are called as organic compounds, and these aromatic this is hydrocarbons here. They are insoluble in water. They are not soluble in water. Here the substances like sodium chloride and sugar is soluble in water, but the substances like naphthalene and anthracene is insoluble in water, and vice versa. Here this and anthracene and this is naphthalene are insoluble in water here, but soluble in organic solvents, soluble in organic solvents like benzene. In benzene, here naphthalene and anthracene are soluble. And this here shows that here, and this is called as polar compounds. This is called polar solvent. Polar compounds are soluble in polar solvents. Okay. Then what about here? This is anthracene and this is naphthalene. Here, naphthalene and anthracene are called as non-polar substances. And non-polar substances are soluble in non-polar solvents. Here, benzene is called a non-polar solvent. Toluene is called non-polar solvent. Carbon disulfide non-polar solvents. This is okay. Based on these factors, here the basic principle of solubility is like dissolve like. Like dissolve like. This is the basic principle of solubility. Like dissolve like. Like dissolve like. Then what is the meaning of that? So this is the basic principle of solubility here. Like dissolve like nothing but polar substances. Polar substances dissolve in polar solvents. And what are polar solvents? Water is called a polar solvent. Ammonia is called a polar solvents. Like this. Polar substances dissolve in polar solvents, and non-polar substances dissolve in non-polar solvents. This is the basic principle of solubility. Then, when a solute is dissolved in water, here, it undergoes dissolution. For example, here this is taken. This is called as water here, and for this water, if you are adding sodium chloride here. When the sodium chloride is added into water here, this is sodium chloride. Initially, what happens here? This is sodium chloride substance in water undergoes dissolution. This is dissolve here. The process of dissolution, the process of solubility of NaCl in water or in a suitable solvent is called as dissolution. This is dissolution. Dissolution means here when the solute added into solvent here, that solute undergoes soluble in a particular solvent here, that process is called as a dissolution. It is. Then initially what happens here, solubility goes on increases. That is, here Na plus and Cl minus undergoes a dissociation here. Then the solubility of this substance goes on initially increases. Then if you are adding more amount of solute, here, then the solute particles which are present in the solution here, they react with it is bombarded with solid materials, solute particles undergo hindered here, that is they undergo bombardment here. They form crystals. Nothing but the solute is crystallized. Solute particles undergo crystallization. This is called as crystallization. Crystallization and dissolution are both reverse process. Dissolution means here the solubility of a solute in a liquid. A process of solubility of solute in a particular solid is called a dissolution here. Then the solute particles which are present in a solution here undergo crystallized here. That process is called as crystallization. Then here after some time what happens here? After some time here both that is rate of dissolution and also rate of crystallization becomes same. Okay. When the rate of dissolution and the rate of crystallization becomes same here, that the state is called as equilibrium state. At equilibrium state here, then we will get a saturated solution. At a particular temperature. Saturated means here that in a solution here no more solute can be dissolved. If you are adding more amount of solute, a particular quantity of solute dissolved in a particular amount of solvent. If you are adding excess amount of solute here, that excess amount of solute is crystallized here, then that solution is called as saturated solution. A solution in which no more solute can be dissolved at a particular temperature, that solution is called as saturated solution. Then what about here unsaturated solution? An unsaturated solution is one here in which more solute can be dissolved at a particular temperature. That is called as unsaturated solution. A A solution here in which no more solute can be dissolved, that solution is called as saturated solution, and a solution in which more amount of solute can be dissolved at a particular temperature, that is called as unsaturated solution. It is. In unsaturated solution, here if you are adding more amount of solute here, that solute can be dissolved here at a particular temperature. That is the difference between a saturated and unsaturated. And during in case of saturated solution here, the solute here plus a solvent here gives it is a solution. There is equilibrium between a solution and that is rate of dissolution of solute and also the rate of crystallization of particles in a solution. That is the solute plus solvent gives a solution, and this is called as equilibrium state is attained. That state is called as the equilibrium state is. And the equilibrium state, what happens here, a rate of dissolution is equal to rate of crystallization. That state is called as equilibrium state in solution. Next here, this is what are the factors affecting on solubility of a solid. What are the factors which are affecting on solid? This is solid, NaCl is solid, sugar is called solid here. And what are the factors which are affecting on the solubility of a solid substances in liquids? Here, what are the factors affecting here? That is, one is temperature. One is temperature here, and one more is called as pressure. It is. And what is the effect of temperature on the solubility of a solid in a liquid? It is. Here, in the dissolution process, if the dissolution means solubility here, if the dissolution process is endothermic, that means delta H solution more than this is 0. Endothermic means positive value. If the dissolution process is endothermic here, as the temperature increases, solubility also increases. Since here, if the dissolution process is endothermic process here, then it absorbs more amount of that is heat energy here. That's why as the temperature increases here and the solubility goes on increases. This is the first case. In second case here, if the dissolution process is exothermic nature, if the dissolution process is exothermic in nature. Exothermic means here delta solution H value is less than 0. That is, heat is evolved from the solution. When heat is evolved from the solution here, that process is called as exothermic process here. If the dissolution process is exothermic process here, then as the temperature increases here, solubility goes on decreases. This is the effect of temperature on solubility of a solid in a liquid. That is, the solubility of a solid in a liquid depends upon the nature of the dissolution process. If the dissolution process is endothermic nature here, then as temperature increases, solubility goes on increases. If the dissolution process is exothermic in nature here, then in this case here, delta H is negative value or less than 0 here. As temperature increases here, solubility goes on decreases. This is the effect of temperature of a solid in a liquid. Then in case of solids in liquids here, solubility of a solid in liquids here, as pressure does not affect solubility. It is. If you are varying pressure here and by changing pressure here, pressure does not affect the solubility of a solids in liquids. It is. Okay. This is about the factors which are affecting on the solubility of a solid in liquids. It is. Then after this here, then you go for this next our topic, that is called as these are the most important topics in this is solubility of solids in liquids. Then what about here this solubility of gas in a liquid? Solubility of a gas in a liquid depends upon it is temperature and pressure. Generally here we come across it is many gases which are dissolved in water. It is many gases dissolved in water. It is here. But some gases are more soluble and some gases are less soluble. It depends upon the nature of the gas, whether the gas is a polar molecule or it is a non-polar molecules, and like that it depends upon the nature of the solute particles. It is. Then for this solute element here, this gas is called as a solute. It is like this. For example, here it says if you are taking water here, this is water here. In water here, there is oxygen. Oxygen is less soluble in water. Very less amount of oxygen is dissolved in water, and this a little quantity of water which is present in water is called a dissolved oxygen. This dissolved oxygen present in water is sufficient here to sustain aquatic life. Aquatic life. All aquatic animals or aquatic life is sustained here due to dissolved oxygen which is present in water. It is okay, and this cold water has more oxygen content when compared to this warm water here, and hot water has less oxygen content when compared to cold water. That's why aquatic animals are more comfort at cold water when compared to warm water. Then more amount of oxygen present in cold water. That's why here the more virus and bacteria which is readily grows in this cold water when compared to this warm water. Then here solubility of a gas. So this is gas where oxygen, O2 is gas, nitrogen is gas, and also it is HCl is gas and SO2 is gas, and these gases are soluble in water. It is water, or in case of benzene, or in case of this is cyclohexane, like the different solvents are used here. It is, and the most of the gases which are soluble in it is suitable solvents. The solubility of a gas in a liquid here depends upon that is mainly depends upon temperature, or one is called as pressure. Temperature and pressure. As the temperature increases here, the solubility of a gas in a liquid decreases. As the temperature increases, solubility of gas in a solution goes on decreases. Here, why here is the solubility of a gas decreases by increasing temperature in case of gas in these liquids? Here, this is mainly due to here dissolution of a gas or solubility of a gas in a liquid is exothermic process. If you take any gas, this is exothermic process. Solubility of a gas in a liquid is exothermic process here. That's why as the temperature increases, the solubility of a gas in a liquid goes on decreases. Okay, this is the effect of temperature and solubility of a gases, in liquids. Then what about here pressure? Here pressure also affects solubility of a gas in a liquid. As the pressure increases here, then the more number of gas molecules dissolves in solution. As more number of gas molecules dissolves in solution, here solubility goes on increases. That's why here as the temperature increases, solubility of gas in a liquid decreases. Since dissolution of gases in solvent is exothermic in nature, that's why here the solubility goes on decreases by increasing temperature. But by increasing pressure here, the solubility of gases in a suitable solvent goes on increases. Okay, that's why as pressure increases, solubility of gas in a liquid increases. These are the two main points about the solubility of a gas in a liquid. And also here the solubility of a gas in a liquid depends upon the nature of the solute. Here some gas molecules are polar in nature and some gas molecules are non-polar in nature. For example, here this is called HCl. HCl is polar molecule, O2 is non-polar molecule, and HCl is more soluble in water when compared to oxygen due to its polar nature. Because water is polar molecule and HCl also polar molecule. Here, what is the basic principle of solubility here? The basic principle of solubility is like dissolve like, means polar compounds are readily soluble in polar solvents. And this is non-polar molecule, this is non-polar solute, this is called polar solvent here. That's why it is less soluble, it is more soluble. This is solubility of a gas in a liquid is. Then here it is as a solubility of a gas in a liquid depends upon its pressure. As the pressure increases, the solubility goes on increases. For example, this is a case here. This is a vessel here which contains this is here water here. This water contains some solute particles, gas particles. This is called as gas particles, like this gas. And this is called as upper layer here. This is called as vapor phase, and this vapor phase contains some of the molecules of gas. This is vapor phase, this is in solution phase, this is called vapor phase. And similarly here, if you draw this is called as this is a piston. This is called piston. You are moving. This is piston. This is frictionless piston. You are moving. Here is this is. Then similarly here you are drawing one more diagram about this is water here, and this is called as vapor phase. When the piston moves downwards like this, downwards here. Then when piston moves downwards here, this is downward. Then here the number of particles in solution goes on increases as by pushing this piston to the downwards. Here it is. Then more number of molecules are present in a vapor phase and also in a solution phase, like this, like this. This is gas molecules in a vapor phase. This is called as in solution phase. Here it is. Then when this piston moves downwards here, then pressure increases. When pressure increases, the more number of molecules are present in the solution phase here, and there exists a new equilibrium between vapor phase and solution phase. The solubility of gases in the liquids studied by Henry's scientist. Henry's scientist was studied about the solubility of gases in liquids. According to Henry's law, here it is. Then Henry's give a quantitative relation between here, that is the solubility of gas, and also it is partial pressure of the gas. Henry was studied about solubility of a gas in liquids here. Then he give a quantitative relation between solubility and partial pressure of the gas here. That statement is called as Henry's law. It is. According to Henry's law here, solubility of a gas in a liquid is directly proportional to the partial pressure of the gas over the solution. That is. Then here, that means it is as partial pressure increases in the vapor phase. This is called vapor phase. As the partial pressure increases in the vapor phase here, then the more number of molecules are soluble in the solution. It is. This is called as Henry's law statement. According to Henry's law statement here, solubility of a gas in a solution is directly proportional to here, that is partial pressure of the gas. Partial pressure indicated by the symbol small p. This is partial pressure is a small p here. Small p is indicates partial pressure. S indicates solubility. The solubility of a gas in a solution is directly proportional to the here partial pressure of the gas present over the solution. Here partial pressure means the pressure exerted by the individual gases over the solution. That is called a partial pressure. As the partial pressure increases over the solution here, the solubility of a gas also increases in the solution. It is. Then this Henry's law also modified as this partial pressure. The partial pressure also expressed in the form of the partial pressure of gas expressed in the form of mole fraction. Is also expressed in the mole fraction of a solute which is present in the solution. Then here according to here this statement is modified by Henry. Here it is, that is mole fraction. Mole fraction symbol we are using, that is this is X is called mole fraction. Here the mole fraction of the gas present in the solution is directly proportional to the here partial pressure of the gas present over the solution. It is. As the partial pressure increases, mole fraction of the gas in the solution increases. That is, this is directly proportionality meaning. Direct proportional meaning it is as a partial pressure increases over a solution, here the mole fraction of gas in the solution also increases. Then this is also modified as here. This in this term modified as the partial pressure of the gas. The partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas present in the solution. This is called as, this is also modified as like this. Here P direct proportionality is mole fraction. The partial pressure of the gas over the vapor phase is directly proportional to the mole fraction of the gas in the solution. Okay, this is called as Henry's law. Here it is. Then this is mathematically written as partial pressure is P, and removing this proportional constant we are adding new constant, that is called as KH, and this is called as mole fraction symbol, that is called as X. It is mole fraction. This is Henry's law constant. This is partial pressure. Then Here partial pressure is equal to kH into this is mole fraction, and this P, this is by kH equal to, this is called as mole fraction, and here where kH is called as Henry's law constant, and Henry's law constant depends upon the nature of the gas it is, and at a particular temperature here different gases have different solubility, different mole fractions, or different partial pressure, different kH values for O2 and N2 and CO2 here, and all these gases have different kH values here. That kH value depends upon the nature of the gases, and also here the kH value also depends upon temperature. As temperature increases, kH value increases. When kH value increases here, then the mole fraction of the gas in the solution goes on decreases. That indicates here, as temperature increases here, kH value increases, Henry's law constant increases. When Henry's law constant increases here, the solubility of a gases in liquid goes on decreases. This is the importance of Henry's law constant. And based on this here partial pressure equal to kH into X here, we are also solving some problems based on this is Henry's law constant here. By knowing kH and partial pressure, we are calculating mole fraction of gas present in the solution. This is effect of temperature on the solubility of gases in liquids here. Remember that the most important point in this Henry's law formula is Henry's law constant here. As Henry's law constant value, kH value increases here, solubility goes on decreases. Since as temperature increases, kH value increases. When Henry's law constant value increases, the mole fraction of the gas in the solution goes on decreases here. The solubility goes on decreases. Then after this here we come across what are the applications of Henry's law. And Henry's law have wide applications here, and Henry's law is used for the manufacture of cool drinks, soft drinks, and also in case of these beverages and cool drinks are mainly used for this Henry's law. Then if you take a graph for this Henry's law, this is called as this is a mole fraction here. Mole fraction of the component like HCl dissolved in cyclohexane here, and if you are drawing a partial pressure, if you draw a graph for partial pressure versus mole fraction here, then you will get a straight line, like this straight line. That indicates here the P partial pressure is equal to kH into X here, and the slope of the straight line that gives the value of kH. This is a mole fraction axis, this is called partial pressure axis. You will get straight line between a mole fraction and partial pressure here. The slope of the line indicates this is called as Henry's law constant. Then after this here, what are applications of Henry's law here? Henry's law have wide applications here in industries here, and for the manufacture of soft drinks, and also beverages, we are using Henry's law. And for the preparation of this is carbonated water here. Carbonated water means nothing like soda water bottles here. R1 is soft drinks, nothing but cool drinks, and cool drink bottles here, soft drinks all are based on Henry's law it is. And the second one here is used for scuba divers, and that is scuba divers must cope with high concentration of dissolved gases while breathing air at high pressure underwater. It is scuba divers carries oxygen cylinders here. In the depth of the sea here, they carries oxygen cylinders here to breathe under high pressure. They are using dissolved gases. The dissolved gases contains helium and a mixture of this is called as oxygen and helium mixtures we are using here, and a small concentration. This is about N2, it is nitrogen gas. If you are not using this helium here, when this air contains oxygen and nitrogen here, if you are using only this O2 and N2 here, then when the scuba divers comes upwards of the surface of the seawater here, then the pressure is less when compared to this depth of the ocean, and the depth of the ocean has high pressure when compared to this upper surface here. When the scuba divers comes upper surface of the seawater here, this nitrogen is more soluble. Nitrogen gas is more soluble in blood here under high pressure here. When scuba divers comes outside from the surface here towards the surface of the ocean, then the more amount of dissolved oxygen present in the blood comes out here, and it creates it creates some pain in the heart here. That effect is called as bends. That effect is called as bends. And there is nothing but here it is more dangerous here, and it creates pain in the chest here. And to avoid this problem here, this air is mixed with some extent of helium, and helium is less soluble in blood when compared to nitrogen. This is a use of that is air diluted with helium. Then after this here, then you go for this third one here, that is at high altitudes. At high altitudes, the peoples living at high altitudes, like it is Kodaikanal or Ooty here, or it is there is Himalayas, or it is like this here, that the peoples who are living at high altitude here, they have less amount of oxygen. They breathe less amount of oxygen. Less amount of oxygen is available here if you are moving high altitudes. Due to less amount of oxygen at high altitudes here, then they take less amount of oxygen in blood here, and it creates a condition here. That condition is called as anoxia. That is nothing but here, the peoples who are living at high altitude have this less pressure here. Due to less pressure at high altitude, they will get less amount of oxygen in blood here, and due to less oxygen in the blood here, they are unable to think properly here. And if they are unable to think properly here, that condition is called as anoxia. It is anoxia condition. It is, and they are weak also. It is, the peoples who are living at high altitude are weak and are also unable to think properly here. That condition is called as anoxia. And these are the three important applications of Henry's law. One is the carbonated water or soda water. This is soft drinks are prepared by the use of Henry's law here. Other one is the scuba divers carries oxygen cylinders are loaded with the helium here. Since nitrogen gas is more soluble in blood when compared to helium, when the scuba divers comes out towards the surface of the ocean here, then the more amount of dissolved nitrogen comes outside here, that causes pains in chest. That condition is called as bends here. And to avoid these conditions, it is diluted with some extent of helium. And the peoples who are living at high altitude have less amount of oxygen at upper surface here, like Ooty, Kodaikanal, there is Everest, Himalayas here, like that. Then they have this they are weak, and also they are not thinking properly here. That condition is called as anoxia. These are the applications of Henry's law. After this application here, then we go for this the next study is called as effect of temperature and pressure. And what is the effect of temperature and pressure? Here, the solubility of a solubility of a gas in a liquid depends upon two factors. Here, we already studied about effect of temperature and pressure. As temperature increases, solubility of a gas in liquid goes on decreases. Since here, the solubility of a gas in liquid is exothermic process. Due to this exothermic nature here, then solubility goes and decreases by increasing temperature. Then what about here? It is by increasing pressure. As pressure increases, and here the vapor pressure increases at the vapor phase here. When vapor phase the partial pressure increases, then the mole fraction of the gas in the solution goes on increases. That's why here, as the pressure increases, solubility of a gas in the liquid goes on increases. This is the effect of temperature and pressure on the solubility of a gas in a liquid state. Okay, I hope you are all clearly understanding these concepts about this is what is solubility here, and the solubility of a solid in a liquid here, and a dissolution, crystallization, saturated solution, and effect of temperature and pressure on the solubility of solid in liquids, and the solubility of a gas in a liquid here, and Henry's law and its applications. And Henry's law, you have different forms of Henry's law. Here it is according to Henry's law, what happens here? This is according to Henry's law here, solubility of a gas in a liquid is direct proportional to partial pressure of the gas present over the solution here. As partial pressure increases, solubility goes on increases, or the mole fraction of the gas in the solution is directly proportional to partial pressure of the gas over the solution here, or the partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas in the solution. These are different forms of Henry's law here, and Henry's law have these three applications. Here it is, I already told this one it is, and the effect of temperature and pressure is most important for exam point of view here. For in case of effect of temperature and pressure here, that is solubility of a gas in liquid is always exothermic nature. That's why as temperature increases, solubility goes on decreases. But in case of pressure here, as the pressure increases, solubility of a gas in a liquid goes on increases. This is about it is this session topics it is. In the next topic, we will discuss about the properties of solutions here, that is called as vapor pressure. R1 is called as Roth's law here. Based on Roth's law, we have these two types of solutions. One is ideal solution, other one is non-ideal solutions, and also it is non-ideals. We have two types. One is positive deviations, other one is negative deviations, like that it is here. Then I hope this is syllabus about this is in this session here. Thank you, and all.